Okay, so this video is just going to go over how to use the runNIRSPreproc script, which is the preprocessing script that's somewhat GUI-like in that you're going to have some pop-ups that come up that are going to ask about your data structure and whatnot and how you want to preprocess. So I'm going to go through different examples based on your data structure. So we're going to start with the most simple first, which is going to be a single subject, single scan. So so I'm going to open up in my NIRS preprocessing pipeline the runNIRSPreproc script. And you actually don't have to change anything. I actually do not change anything for this script, as this script is it's fully automated. So it's going to ask you for all the details. So just so we know, I have 4 different data files here on my desktop. And the first one we're going to start with right here is the single subject, single scan. So right now I just have 2 subjects in this data structure, and what you'll notice is that I have SS in front of both of them. So that's my data prefix. If you're using this preprocessing pipeline, always make sure you have the same data prefix for every subject and folder, or else it won't get preprocessed. And then I also have a number, which for me that's my subject ID. So this was probably like subject 5, and this was subject 41. And then I have the name of the scan. And then inside of this folder, because it's single subject and single scan, is just the actual data. And this was collected with our NIRSport2, which gives us both a snrf and NIRS file. Alright, so let's pre-process that data. So all I have to do is click Run on this runNIRSPreproc script, and what you'll notice is I don't even have my folder and subfolders active, because if I hit Run, it's going to say, do you want to add this to the path? And you can just add it to the path. Boom, added all of the folder and subfolders. So my data prefix for this study is SS, and then it's not a hyperscan, meaning I didn't scan multiple subjects at once, so I'm going to keep that as 0. It's not a multi-scan because there's only 1 scan per subject. And then for this one, I do not believe I had any auxiliary, so no accelerometers or anything. However, if you do have accelerometers and you put 0, it actually still will compile them. So not too big of a deal. However, it may not trim them. Alright, so I'm going to hit OK. So now it's going to ask what kind of motion correction I want. So you have a couple of options here. First and foremost is that if you choose PC filter, you must have the mapping toolbox from MATLAB or else it won't work. And then I do recommend Wavelet. It seems to be the best so far, personally. I've included all of the supplemental scripts to do it. And then I wouldn't ever really do none, meaning no motion correction, unless you want to just compare like no motion correction versus any of the selected motion corrections here. For short channel regression, I don't think this is fully updated yet, so just be aware that it might not be fully functional. I will have it fully functional soon, but just make sure that it is working if you do use it. However, for speed, baseline volatility is the quickest, so I'm going to select that right now. Alright, so now it says select an acquisition device. So if you collected with the NIRS Scout, it doesn't have a .NIRS file, so please make sure you select that if it was with the Scout. If you collected with the NIRSport2, or you just have a .NIRS file, you can just select this one. And then, if you only have a snrf file, you can select this, but you must have Homer3 in the same current directory. So if you see over here, I have Homer3. However, I'm going to use the .NIRS file. Alright, so now this is asking me, do you want to do a data quality check and compile all of your data? Meaning, instead of just getting a single .map file for every subject and scan, we're going to take all of the scans and subjects and compile it into one .map file. But the first thing is quality check, which is just what channels you lost per subject. If you don't want to do that, you can say 0, but I'm going to say yes. Then it says, what's the length of your ID? So this is after the data prefix and before the scan name. So in this example, my data prefix is IPC with an underscore, 3 numbers, another underscore, and then the name of the scan. So my ID length would be 5. However, for this study, let's just take a quick look so we can remember. So you'll notice I don't have an underscore here, so that means that after my data prefix I have 4 characters. So 3 numbers and an underscore, and then the scan. So the length of my ID is actually 4 characters long. Alright, I do want to compile my data into one .mat file. I only have one scan. This is asking if I want to compile the z-scored or just like the non-z-scored data, so I'm going to say no. This is only because I think it's quite easy to z-score later on, like before analysis if you want. And then channel reduction. So 1 means that you're keeping your oversaturated channels. Again, I don't recommend this. It's similar to no motion correction in that I would only ever select this as a comparison. I usually select 2 or 3. 3 is if I really think there was a lot of motion in the data, and that's what it's doing is it's getting rid of oversaturated channels and then also getting rid of channels that even after motion correction we're uncertain if they're reliable because of all the change. The change is like above standard deviations of normal change. So I'm going to do 2. Alright, and then do I want to trim my scans? So this is only based on trimming off the beginning because the beginning of scans are often really noisy as we're still like, the participant might still be moving around, we haven't really started the actual experimental part. So usually what I do is I trigger before whatever it is I want to look at. So I like to trim off the really noisy part of the scan before pre-processing so it doesn't bleed into the rest of the scan. So we can select a couple of things, but for this example, I'm just going to trim based on my first trigger, meaning whatever the first trigger is in each scan, I'm going to trim off everything before that. Alright, so now it's asking where is my data located on my computer. So on my desktop, and it's in NIRS. And now we're pre-processing. So in your command window, it's going to actually show you what subject it's on, and then it's going to give you just like an elapsed time. So then that way you know it's working and how long it's going to take you for different types of things. So it doesn't actually output anything in your workspace, but it will create a new folder. So if you look here, called preprocess files. So let's take a look. Alright, so we have both the subjects. So if I go into this first subject, we see that there's 3 .mat files. So we have the preprocessed no noisy channels, and preprocessed no uncertain. So I explained this earlier with the compile. So this one is going to include all channels including saturated. This one does not have saturated channels, and this one does not have saturated or uncertain channels. So this is for the individual and the individual scan. And then we also have this channel MNI coordinates. So this is the MNI coordinate for every channel. So this was 42 channels, so all the way down to 43 because that first column was just XYZ. And so this is channel 42 in your X, Y, and Z space with MNI coordinates. So that way you can later visualize your channels for analysis and for presentation purposes. So this goes into every scan for every subject. Alright. However, you might not want to work off of the individual .mat files, so I have this thing called a compile, and what it is it compiles everything. So we'll take a look at that real quick. So you'll get deoxy and oxy, and then because this is a single scan, we're not going to get like rows and columns, we're just going to kind of get these variables in here. But it gives you the name of the scan, which was outgroup, your subject data, so it's going to be time by channels, by subjects, we only had 2 subjects. Then you get your time, so time in seconds. If you want, you can take a look at that. That's dependent on your sample rate. We have our triggers. So just for this, because I trimmed it based off of the first trigger, the very first variable is yes, it's a trigger, and then the rest are no, it's not a trigger. I have my auxiliary. So like I said, I wasn't sure if I had auxiliary, but it still compiles it, even if you say I have 0. So these are accelerometers. I have my sample rate, which is about 5 samples per second. And then I have this last variable, which is dependent on whether or not I choose to do a quality check. And this is your lost channels by subject. So we had 2 subjects, and you can see for subject 2, which is row 2, it doesn't seem like I lost anything. They're all zeros. For subject 1, it looks like I lost a lot of channels. So just so you know, so like lost channels 35 through 39. So this is just a way to have like a nice variable for knowing which channels you lost per subject, and then you can also like sum it to just see like, okay, how many channels across all subjects did I lose, or how many times did I lose channel 9 across all subjects? That's up to you. All right, so that's that compile. I'm going to clear this real quick. And then last but not least, these are just CSVs if you prefer this for your lost channels. So it does it in two different ways, which is you have your channel, so 1 through 42, and then how many times did you lose it for that scan. So we have two subjects, and it shows me channel 2, I lost it once out of 2. Channel 5, I lost it once out of 2. So if you have 0, it means you didn't lose any channels. All right, and then this is just a different way of looking at it, which is for subject 1, how many channels over the 42 channels did I lose? So subject 1 lost a lot, they lost 17 channels, and subject 2, we didn't lose any. So no oversaturated channels, no uncertain, or actually no oversaturated, because I didn't compile the uncertain. All right, so that's the output for pre-processing. So you can work off the compile, which has like all your subjects and all your scans, or for analysis, or you can like work off the individual .mat, depending on how you like to write your analysis script. All right, so that's single subject. So let's look at a little bit more complex, which is going to be single subject with multiple scans. So here we have 3 subjects, and then inside we have 5 different scans. And then within each scan folder, we're going to have the actual data. All right, so this was also collected with the NIRS support. But what you might have noticed is that I have a couple of extra files here in my overarching data folder. So the first thing I'm going to show is the trimtimes.mat. So in the previous one, I trimmed with the first trigger, but you can also trim with a .mat file or a .csv. So if I wanted to, let's say, I wasn't sure if all the triggers were there or correct, or something happened in data collection where the triggers are just wrong and I don't want to fix them all, but I have the correct times. I can make it into a mat file, and here we're seeing it's rows are subjects, so I had 3 subjects, and then columns are scans. I have 5 scans. So this is for subject 1, scan 1, subject 1, scan 2, and so on. So these are the frame in which to trim off everything before. So at frame 512, I want to trim off everything before that and then pre-process. Make sure that this is in the correct frames. So frames is dependent on your sampling rate. This is not seconds. If I had a hyperscan, this would actually be a 3D structure in which it would still be subjects and scans, and then I would have my third dimension, which would be like subject 1, subject 2 for that hyperscan. But this is single subject, so it's just 2-dimensional. Okay, I'm gonna just clear that real quick. And then the second thing you might have noticed is this thing that says SD fix. And the reason for this is that there was a mistake during data collection in that for one of these subjects, the wrong probe info file was used. It's still, though, it wasn't so wrong that it collected the wrong data, it just was a little bit off in, I think that they didn't have accelerometers or something, or it didn't output the probe info file. So for this subject right here, it has that probe info file, and it also has the digital points. But if I go to this subject, you'll notice I don't have a probe info file, nor do I have the digital points. And I need that to run my pre-processing. So what I do, if this happens, if for some reason the NIRS support or Scout didn't output the probe and the digital points, you could hypothetically go into every single scan and copy-paste them in, or so I can just go into one scan from a subject that has the correct probe info and digital points. I can copy it. So I did a control copy, but just so you can see it, copy it. And then I can come out here and I can paste it. So it would look something like this, right? But I'm just going to replace it, that's fine. And so I put the digital files here, and then for this I would rename it into SDFix. So I'm just going to delete this for now. And the reason for this is if there's ever a subject and scan that's missing the probe info file, the script will go, okay, we're missing that file. In the overarching, do we have an SDFix and digital points? So the script will actually check in the overall data folder if these two files are in there. And then it will apply it to those missing the probe info file. So you don't have to go in and like copy paste and then copy paste or like write some script for it. It's already in the preprocessing. If there's a subject missing those, just make sure you have SDFix and digital points, and it will apply it to anyone missing those probe info files. All right. Whew. So let's run this with preprocessing. So again, this is single subject with multiple scans, and it was done with the NIRS Preprocessing. All right, so I just come over here, and I'm just going to hit run. So my data prefix is SIM. It is not a hyperscan. It is a multiscan, so I'm going to put 1. I believe there were 2 auxiliary. And I'm going to hit OK. Again, I'm just going to choose baseline volatility because it's quicker. I'm going to choose the NIRS Port 2. I'm going to run a quality check. For this one, the ID length is going to be 5, but let's just take a look again. So if you notice, 2 underscores and then 3 numbers, meaning 5 characters between that data prefix and scan name. I'm going to compile my data. This one is 5 scans. I don't want to do z-score, and let's just do noisy and uncertain. All right, and so now I'm actually going to choose to trim with this .mat file. So I'm going to hit OK, and then it's going to ask me where my data is first. So here's my data in this folder. You can also click into the folder, doesn't really matter. It's also going to ask me where that .mat file is for trimming. I like to keep it in the same data folder so I know where it is. I just click on it, open it up, and we're preprocessing. So great. Again, down here you know where you're at, which is nice. If you have like a really big data structure and maybe you're doing wavelet, it's going to take a while. So you could like go and do other things and come back and see where it's at. But we don't have too much data, so it should be pretty quick. All right, so 20 seconds, not bad. So let's go back to this folder, and now we have this pre-processed, and same thing. So for each subject and each scan, we get those 3 .mats as well as the MNI coordinates. And if I want, I can just work off of this compile. I'm going to show you how it looks a little bit different if you have multiple scans. So now we're getting this like row and column structure because we have multiple scans. So each row is going to be a scan, and then we have our subject data and our time and our triggers and auxiliary and our sample rate, and then also our lost channels per subject. So to take a look again, we had 3 subjects, and there's our lost channels. So this was some pretty good data. As you can tell, we didn't lose a single channel out of these 3, and this is even with the uncertain. So good data collection there. All right, so now I'm going to clear that. Let's look at what it's like to do hyperscanning. So I'm gonna close this out. So now I have this example, which is going to be hyperscan data with a single scan. So we have dyad 1 and dyad 2. Then I have subject 1 and subject 2. And so if you notice, it's the same name because it is the same scan. And then within there, I have my actual data. So this was collected with the NIRS Scout, because as you notice, you can't see the .NIRS or the .snrf file. So let's click out of there. And then this, for this one, we're going to just do it with the first trigger. All right, so let's hit run. All right, so HS is my data prefix. It is a hyperscan. Also, it is not a multiscan. So I'm going to keep that 0. There were no auxiliary for this one, so I'm just going to keep that 0. We'll just do baseline volatility for speed, especially because this is a NIRS Scout. It's actually going to take just a little bit longer for pre-processing because there's not an existing .NIRS file. So I'm going to keep it on NIRS Scout. I'm going to run that quality check. For my ID length, let's just double check. I believe it's 5. It is 2 underscores, 3 numbers, 5 characters. Let's compile my data. This is just one scan. We could do the z-score if we want, and we'll do just rejection of noisy channels. All right, so I'm going to trim based on that first trigger. It's going to ask me where that data is. So hyperscan, single, and we're preprocessing. What you'll notice is that this is a bit slower, not necessarily because it's a hyperscan, but because it's with the NIRS Scout. It just tends to go just a skosh slower, but still pretty fast. All right, so in my overarching folder, again, I now have a preprocessed files. Oh, that's strange. There we go. Let's see. It doesn't seem like it did my subject 2. So let's take a look at that compile. Let's pop that over here. All right, so it seems like what happened is that it only compiled, oh no, we're good, we're good. It compiled, so this is a single scan, so, but hyper scanned. I like how I'm getting confused by my own things. So because this is a single scan, we don't have that row by column structure. Instead, we have the name of the scan, and then what we have is subject 1, and then this is actually going to be subject 1 of all the dyads. So we had 2 dyads, so it's going to be time by channels by the first subject of every dyad. And then same with time, triggers, auxiliary, and then we have the subject 2. So subject 2 is going to be subject 2 of all our dyads. So in this 3D structure here, we have dyad 1, subject 2, dyad 2, subject 2. Hopefully that's not too confusing. And then, so everything's doubled basically, except for our sample rate because it's the same across all subjects, and the name of the scan. But everything else is also unique to the subject, including those lost channels. So let's take a look at the lost channels. So we can actually see for subject 1 in dyad 2, we lost channel 1. But if I open up subject 2, we can kind of see that difference because these are different subjects. So again, dyad 2, subject 1 and 2 both lost channel 1, but in subject 1 and subject 2 for dyad 1, we did keep channel 1 for at least subject 1. All right, so that's hyperscanning with a single scan. So I'm going to clear that. And last but not least, we are going to look at hyperscanning with multiple scans. So that's this last example here. Again, I just have 2 dyads. This is just for speed. And then within each dyad, we have each subject, and then we have the 3 scans. So depends on how many scans you have for your data. This one has 3. And again, this was collected with the Scout, not the NIRS Sport, so we don't have a .NIRS or .snarf. All right, and then I'm going to show you what it's like if we trim with a spreadsheet. So this can be a CSV, an Excel, just anything that's spreadsheet style. I'll show you what it looks like. So unlike the .mat, this actually has the names of the scans, and it will know based on a spreadsheet to not like import the names of the scans. This is just for your own sake. But because this is a hyperscan, we have the first subject scan, the first subject second scan, first subject third scan, and then we have the second subject first scan, and so on. If I had, let's say, 3 subjects that we hyperscanned, I would just do this, and then I would continue on. So you can have more than 2 subjects per hyperscan, and it will work. All right, and then we have the dyad. So this is dyad 1, dyad 2, and so on. The trim for both subjects is exactly the same regardless of the scan, and that's because they were always scanned together for every scan, so they were hyperscanned for each. Every once in a while, depending on your data structure, like you might have some scans hyperscanned together and then some different. In that case, just make sure you have the right trim times. All right. I am not going to save that because I don't want to make any changes. And let's do hyper multi. All right, so it's HM. This is a hyperscan, so I'm going to say yes. It's also a multi-scan, and I didn't have any auxiliary, so I put OK. I'm going to select baseline volatility for speed. Keep it as the NIRS Scout. Got to run a quality check, and then I believe this one was also 5, but just in case, yeah. So 5 characters long. Sorry, I didn't vary this very much on ID length, but I think you guys get the point. I'm going to I'm not going to compile my data. So as an example, I'm going to show you if you choose not to compile your data, you can do it later. So let's not compile. Technically, if you're not compiling, you don't need to put the correct number of scans. I'm just going to do it anyways. All this other stuff, you could put 0 or 1. It doesn't matter. All right. And we are trimming with the spreadsheet this time. So I'm going to select spreadsheet. So first, it's going to ask, where's the data? Hyper multi. And where's the spreadsheet? So just like the .mat. And I click on that spreadsheet. And we're preprocessing. Again, it goes a little bit slow on this because it is with the Scout, but it shouldn't take too long. We're already, I think we're almost done with the first dyad. So this time in our preprocess folder that it creates, we're not going to have the compile.mat because we chose not to compile it. Instead, we're still going to get all of the those 3 .mats for every scan, but this is just to show you that, like, if for some reason you don't want to compile it while preprocessing, like maybe you want to add some stuff later, or you're preprocessing like half the subjects now and preprocessing half the subjects later, there might be a reason why you don't compile. So let's see what that compile looks like. So again, preprocessed files. You'll notice no compile, but we do have our dyads and our subjects and our scans, and we have those 3. You'll also notice I don't have the MNI coordinates, which you can also make afterwards. So if for some reason it doesn't make your MNI coordinates, don't stress, there is a script for that. Okay, so let's compile this data. So let's say I preprocessed it, and then I preprocess some later. What I can do is go into helper scripts and do compile only. So compile only, we do have to set our properties. So make sure that you change these things to align with the actual data. So this was a hyper multi. My ID length is 5. I want to do a channel rejection of 2. It is a hyperscan. And I have 3 scans. And I don't want to z-score it. And just to double check, I believe it was 3 scans. Oops. Here we go. Yeah, it was 3. Great. All right, so once I change my properties, then I can just hit run. It's going to ask me where that data is. If I remember correctly, it is the overarching, not the preprocessed, but let's see, it might error out. No, it did it correct. Yeah, so you're overarching. Don't click on preprocessed files or folder. It will actually know to go into your preprocessed based on just this line of code here. So it actually outputs everything right now. So if we wanted, we could actually look at my Oxy 3D compile. And what we see here now is that row and column structure again, because I have multiple scans. So scan name, subject 1 for all the dyads. So that third dimension again is dyad. Same with time, triggers, and auxiliary. So I was going to say, I was like, I don't think there was auxiliary. Sometimes it will compile auxiliary even if you don't have anything. So you can just ignore it. Apologies. All right. And then we have our subject 2 for all dyads, and same with time and triggers and auxiliary, and our sample rate. All right,